In this video, I'm going to go over one of the most common ways of making an ester, and that is Fischer esterification. So in Fischer esterification, I go from a carboxylic acid to an ester. And to do so, I react it with an alcohol and then a strong acid catalyst. So what's beneficial for the Fischer esterification is the solvent I use is the reactant. I can just run this reaction in methanol, say, and I'll get the ester if I'm looking for the R group right here to be a methane group. Okay, so what is the mechanism of the Fischer esterification? So I have my carboxylic acid. Step one, as in many of these mechanisms, is going to be a proton transfer. So that's what the strong acid catalyst helps with. I've got hydronium now, and I protonate the oxygen on the carbonyl to make the carbon more electrophilic. Next is the nucleophilic attack, and this is going to be with whatever alcohol we're using. So in this case, I'm going to use ethanol. So ethanol comes in and attacks. Next, I'm going to need to deprotonate the hydrogen from the ethanol that was just added, since I have a positive formal charge on that oxygen. So to deprotonate, I'll use water. Okay, so at this point, I'm going to need to protonate one of the alcohol groups, the OH groups, because I need to get rid of one of those if I'm going to ultimately end with my ester. So one of these will be protonated. And again, protonated with hydronium. If you just put H+, since you have a strong acid, that would be okay as well. But the hydronium is more likely what it's going to be in solution. Okay, so now the lone pair from the OH comes down in to form the double bond, and we kick off the water. So last step is going to be to deprotonate the carbonyl to get my final product. So I'll deprotonate again with water to get my ester. So that is the Fischer esterification process. If I want to go from an ester back to a carboxylic acid, I just do the reverse. I use water and a strong acid as the reactants, and I can go from the ester back to the carboxylic acid. The same mechanistic steps, just in the opposite direction. So we'd protonate the carbonyl here with H3O+ to get the OH+. Then that would react with water, and you just go in the opposite direction back to the carboxylic acid. So if you really want to practice the Fischer esterification and then the hydrolysis of the ester, try to get in the reverse direction and see if you end up back at that carboxylic acid.